like to start with the acknowledgements. Dr. Rutra Mitra, he has been with me from the day one to generate this virtual reality, virtual mind concept. And I'd like to thank to him. He's here. And also School of Mining Engineering and Faculty of Engineering for the financial support developing virtual mind concept. So when we hear the off-earth mining, suddenly some questions come to our minds, obviously. When it's going to start, who will be involving, what we're going to extract, and we heard many hows from Hajima just now, and how we're going to do it. And one of the questions, why we're doing this as well. So as mining engineer, I'll be focusing more to how question, and leave the other questions, which we might also involve what and why as well, but I'll leave the other questions to lawyers, government representatives, and companies, CEOs, etc. We engineers like to overcome challenges. So challenges of earth mining, I'm sure you can name thousands of them. We'll hear from Renee this afternoon, I guess. And yeah, first ones are environmental challenges, gravity, fragmentation, energy, materials handling, beneficiation, friction, temperature, add thousands of them. But first question comes to my mind, what mining methods could be used? To be honest, almost none of the current methods will be directly applicable of earth mining situation. Yeah, obvious one, strip mining for lunar regolith as a surface coal mine, with big modifications, of course. Organ mining or dry dredging. So these three come to my mind straight away. However, I mean, we'll listen from them, we'll heard from him yesterday. There will be no new innovative technologies and methods will be used. So the question is, are those new innovations practicable and possible? But not only physical, but also economic risks, environments, politics, and legal uncertainty. So my talk will be looking at more bigger picture rather than going technicals. As mining engineers, we deal with many uncertainties. So first one, Mother Nature. I think we need to find another term for off-earth mining concept. I don't think we can call Mother Nature. But, you know, first thing in Mother Nature, geological uncertainty. What we say, I mean, all proverbs from mining guys, miners say that where she be, there she be. Wherever is the deposit, we go there and we do that. We do mining there. So asteroid, Moon, Mars, Venus, we'll see. So these geological uncertainty constantly changing as we add more data, drilling data, surveying data, etc. Another one is human nature. So economic uncertainty. It's also very dynamic and constantly changing too. So, I mean, so far no one discussed about the economics. So it's good we can drill, it's good we can dig it out, but how much is going to cost? Or how much we're going to sell the material? So if you look at the current mining environment, economic environment in the world, mining companies decide the operations based on the supply and demand. And today they decide, because of copper gold price increase for the operation, next day they decide, I mean, it's not in days, but they quickly change the decisions based on the commodity prices. So it's going to be applicable for off-earth mining as well. Even experienced mining professionals take a lifetime to build an working appreciation to develop how our work fits into the bigger, longer-term picture. At all mining project planning stages, feasibility studies are presented separately using different conceptual and software modeling techniques. As mining engineers, we have ability to make technical specialist decisions And also we take into account the wider implications of being in a complex, dynamic, often messy, and unpredictable social, political, and environmental context. So it's our role as a mining engineer is not just digging up the material and selling the customers. It's not. We have to consider all this. That's why mining engineering is very multidisciplinary. We have to consider all the other disciplines involved. Even if we don't think, we don't think, but actually we do think. We refer this as a systems thinking. Currently, no means of bringing all the simulation tools together that we, the professionals, can experience and make the decisions, the whole systems in mining projects. Let's stop there for a while and discuss our capabilities here and try to link both. So what is the School of Mining Engineering of University of New South Wales capability? University of New South Wales has been world leader in the development of innovative virtual reality, shortly we call VR, technologies, over the last 10, 15 years. The School of Mining Engineering was also involved in the University of New South Wales award-winning iCinema Advanced Visualization Interaction Environment, shortly called AV, project, and three-dimensional 360 virtual reality facility and IDOM. So hopefully you'll be experiencing this during the lunchtime. I'm going to announce at the end. So this photo is on the left, and big picture shows an AV facility, and the right hand side you can see the IDOM facility. So the school was funded partly by a federal capital development grant in 2007 to develop mine safety training simulations. What you see in the pictures are, actually there are two facilities in the University of New South Wales. One which you will be seeing today and tomorrow during the lunchtime at iCinema Research Center. It's owned by the University of New South Wales. And also second facility is in our school, in the School of Mining Engineering building. Slightly smaller diameter, which iCinema has 10 meter diameter, the school facility has 7.5 meter diameter. Same technology, same facility, which we only use our mine for the mining purposes. So what we have so far, we call little modules: hazard awareness, isolation, outbursts, spontaneous combustion, diffuse inspection, self-escape, which is a photo for the self-escape. It's obvious they're running out from the mine, to train these workers, mine workers, escaping from the, any unwanted activity, and rip stability, and also track inspection. So those first 8 modules, as I said, first, they were, we developed those modules first, and for the New South Wales coal miners, and currently those 8 modules successfully used to train the coal mine workers in New South Wales. We have also some special virtual reality modules working at Heights and North Parks mines, and also some education modules like laboratory rock testing, and also mining in a global environment. So these mining in a global, above mining in a global environment modules, those gray ones, are purely use the game technology, but the mining in a global environment and also surface coal mine are a bit different in terms of not using the game technology. We have 360 cameras or 360 video cameras and spider cameras. We record at the site. In this case, it's called surface coal mine. We record the videos and show them in 3D, not 3D, 360 screens in our facilities for purely education purpose. We widely use this in our undergraduate and postgraduate mining engineering program. And also we have some mining method animations modules like block caving or long wall top wall caving. We also use them in education purpose. We have also track and shovel module, which was one of the first interaction between Excel calculations and engineering calculation in Excel for the track numbers and productivity, etc., and visualize them. And the last modules we developed, we mine, virtual mine, 1 and 2 modules, which I'm going to talk about soon. So we talk about virtual reality, but what is the real definition? So one of my colleagues, Andrew Squares, he made a definition in 2001. He said that three-dimensional computer-generated representation of real or imaginary worlds with which a user can have a real-time interaction and experience some feeling of being present in those worlds. I think it's a great definition which really serves the purpose. So what is vMine then, virtual mind? That's our definition for virtual mind. A tool for students, engineers, professionals to experience various aspects of a mining operation, working together, integrating several types of simulation into one environment. So when you read that, it's very difficult to understand. You've got to experience, I hope you can, during 2 days. First module was fully focused on education, and we just wanted to try the interaction between an algorithm done in Excel, Microsoft Excel, and visualize those results. So we had a module called mining method selection, and we have 14 different terrain scenarios, like developing city here, and we put the actual real block model, mineral deposit, under this selected terrain. And then we are able to change the depth, easting, northing, and deep, etc. Now we got a new deposit under that selected terrain. What students do, answer the questions like about the deposit, depth, thickness, etc. And the system just give them the possible mining methods as ranked. So in this case, open pit had the highest number, which is recommended for this. Don't consider that the developing city. No, it's not going to happen. So the deposit under the developing city, open pit we can't use. The students should go to underground, or depends on the regulations and laws. Maybe there is no mining. So that's why students use this in the first and the third years. Depends on the different, depending on the details of the assignment. And also these two modules are available at our website, and currently more than 20 schools in the world using freely. So if you are interested, you can click the website and put your details and then get and use it. So when we create that, we think that how this type of visualization can benefit systems thinking. So today, I heard also Gordon talk about the system. I guess the answer is by improving the ability of professionals in the mining industry to take into account the long-term and environmental consequences for their financial and technical decisions. Okay, so we got a little animation. This is not actual one, this is animation, it's video record. So if you want to see the actual one, you have to go to ICMA. Okay, it's a scenario either in Midwest New South Wales or Hunter Valley in New South Wales. So we select the, you can add the more. This is actually Google Map image. You can add any image. So what I want to do is just to quickly explain here. So what you see is a topography, right? So you can see some hills and some valleys, etc. So what it does, we've got the Midwest New South Wales Google Map or Google Earth image, okay, wherever you want. In this case, Midwest New South Wales. And we got the actual mine data. block model data, mineral deposit data, and also topography. What we did, we merged this topographical data to selected any image, Google Earth image. So what you see here, if there is a hill there, it means in actual mine data there is a hill there. So this is, you can see only not in 360, but you will be experiencing at ICE now in 360 surrounding. So we got some project details, and you can add some documents like PowerPoints or any documents. And these are some project information. So we add the deposit underneath. There is no mine yet. So that's the surface area. We've done some optimization by using a mining software. These are the optimization results or scheduling results. We have also designed the pit. We also designed the pit in another mining software. So what we've done, we merged 2-3 different mining software outcomes into this immersive environment. So currently, if you realize, we've created the pits, which is ultimate pit means, as you understood, that's the final pit. It's 10, 15 years, whatever. So these are the pushback one means maybe 3-4 years period of the mine. So you can add the cost information and also project evaluation, which we've done, net present value analysis in Excel, and we implement, which this system is reading the results from the Excel file, and we run the sensitivity analysis. Think about as a full feasibility project or pre-feasibility project, let's say. So I need to, I guess, speed up. So what we need to do, next step is the selecting the appropriate equipment. So we got range of equipments designed on the CAD, from CAD drawings, trucks, and these are the major ones. So currently we talk with the Liver and CAD to get and sending to get their design, CAD drawings. We are happy to put their logo there, and wherever using, they can pick any equipment from the database. So what you see here is the first animation we developed. What you will see at iCinema, which will be much better version, because we fixed a couple of bugs and etc. We didn't record the animation again. So then we selected equipment, we designed the mine, we designed the pit. Now we're gonna put the surface infrastructure. You see the whole road's already been there. Designing another mining software, we implemented that in this visualization tool. So, okay, you can go underneath, you can see the deposit in different periods of time. Full, I think it was 14 years, the ultimate pit. And you can see from underneath, you can go anywhere and have a look how it looked like. Now we're gonna add the ruler. We got ruler function, we can see how many meters, and we added distance as well as the slope as well in, you can see in iCinema. So that's the, if you ever play the SimCity, you'll see lots of things like SimCity. The idea came to our mind from SimCity, and also something else I'll tell you at the end. So you can easily create your whole road, and you can get the information, the thickness of the, width of the whole road, and also you can associate with cost. It's not there yet. So you can put the surface infrastructure. It's like a gaming technology, but does make sense in terms of mine planning stages. So it's the tailing dam. So some surface infrastructure. Oops. Okay. So processing plant, workshops, etc. You can add and play, and what you can do, you can associate with the costing and environmental constraints and community, etc. Depends on your project. And you can go to the buildings as well. The next stage, obviously, what can be added? You can go to building inside and look at the mill, hydrometallurgy, whatever it's not there yet, but can be done. So we create the waste dump, and we put the trucks, 5 trucks, and run it. So you see the trucks running now. See, the truck's running, the excavator running down there, the dozer is working. So it's live line, interacted and integrated using different simulation packages in one environment. So that is the uniqueness of the idea. Okay, so let's move on. The aims: to provide a framework to allow to build a simulation model of an authentic mining operation, to improve the current visualization tool, to include an integrated simulation environment which combines use of technical, environmental, and socioeconomic simulations. It's a novel decision-making approach. It can be used for the feasibility studies. To improve and fasten the decision-making process. To give users experience of the consequences of technical decision, and also learn from the mistakes. So what can go wrong, you can see in the virtual environment without causing any loss of life and damage to property. I'm not even going to talk about the learning and teaching benefits, which is obvious, which we are using right now in our postgraduate and undergraduate program. So, virtual reality technology has been mainly used for training purposes to simulate the current situation. VMine is a simulation tool to predict future. Okay? What do I mean? Now, okay, people may think that, okay, we got a colleague in State University of New York, and he's using virtual reality in CSI type of work to understand the direction of the bullets for the forensic investigation. He's working with FBI and New York Police Department. He's mining engineer too. Okay? And another example coming from the aviation, obviously, in the disasters, what they see, they simulate the disaster, and what they do, they look at the response of the pilots. So, okay, it's little predicting the future as well, but the thing is, it's none of them integrating the system approach, using the different simulation done by the professionals and integrating in one immersive environment. Visualizes engineering design and calculations, uses what-if scenarios to make decision fastest, and VMine 1 and 2 are the proof of concept studies. Technology is available, can be used. What was also important, the awareness of the capability of the virtual reality technology. That can be used to visualize the engineering design and calculations. That's the uniqueness also. And it's a great potential to use technology, this technology, to simulate new and novel mining methods systems, such as off-earth mining. I can assure you that the off-earth mining is not going to look like that. I'm using off-earth mining, avatar movie in my first year class. I've got some couple of students here, they can tell the truth, but I show them what was wrong about avatar movie. It's not going to look like that. If you listen to Chris yesterday, and maybe he will talk about tomorrow again, Chris, thank you. The power we use, it's not going to be too big equipments. It's not going to be like that. And I can see as a mining engineering point of view, there are lots of safety concerns on that. It's not going to look like that. But it will be blind like that. It's like that. We're getting there. It's going to look like that. The mine planning project team will be look like that, except they're playing golf. I'm focusing this section actually. Oh, sorry. This section, not the golf, but depends on the boss. So I'd like to thank for the opportunity, and also I just want to remind you, 360 virtual mine demonstrations will be available during the lunch breaks at iCinema. Capacity is 20 people, so we'll do 20-minute sessions. So if you are interested in both days during the lunch times, please put your name into the registration desk, and you can go visit, and I mean, you'll be more understanding this concept, and we can discuss later if you want. So we are open to any suggestion, any improvement. That's the beauty of having different disciplines into one room and discuss the opportunities. What we say in mining, miners like to be first to be second, okay? So we like to use the technology only if it's been proven somewhere else. Because as many of you know, it's extremely risky business. I'm not saying dangerous, okay? We don't use these dangerous, but risky business. It's up to us to manage those risks as engineers. Thank you.
Hi. You mentioned you've done some work on integration of mine planning across different time horizons into your model. I don't know how deep you've gone with that.
Yeah, it's
short-term planning, medium-term planning, strategic out there stuff. Have you guys paid any attention to or done any work yet in finding a statistical basis that lets these things work together neatly? Some kind of Bayesian quantification of uncertainty or something extrapolated from hydrogeology or?
No, not yet, but that's definitely, I mean, I talked to a couple of, not mineral processing guys, but talked to the mathematicians to improve the optimization of visualization actually. I'm going to talk to Gordon as well on artificial intelligence, how can we implement artificial intelligence, so definitely, but we haven't yet.
You mentioned Andrew's work before, so I guess you're working at IVAC as well?
No, but I know Andrew from South Africa.
Okay.
He's in Perth right now.
Yeah.
We had a working group on virtual reality. Thank you.